All right, we are looking at recursion, and really it's all about kind of what the notation means. So this is saying that the sixth term is 8, and we're trying to show that that really is true. So right here we have that the first term is 1, and we have that the second term is 1. So if I were saying that this is my, let's write it on another piece of paper. If I have my term and my t of n, so if I have my first term is 1 and my second term is 1, my third term here would be t of 3 is equal to 3 minus 1 is 2. So t of 2 plus 3 minus 2 is 1, so t of 1. So in other words, my third term is equal to my second term plus my first term. So 1 plus 1 is 2. Okay, so let's look at my fourth term. My fourth term, t of 4, is equal to 4 minus 1 is 3. So I need t of 3 plus, this is 4 minus 2 is 2, so t of 2. So I need my third term plus my second term is really my fourth term. That means these two. I don't know if you've noticed so far, but what we're saying is that to find a term, you add the one before it and the one before that. So to find this term, we added the one before it and the one before that. To find this term, we added the one before it and the one before that. So to find our fifth term, we're going to add the one before it, because that's what t minus 1 means. So if this is t of 5, 5 minus 1 is 4, so t of 4. Plus 2 before that, so 5 minus 2 is 3, so in other words t of 3. So these two terms give me my fifth term. And then my sixth term is the one before it and the one before that, which will be 8. So again, t of 6 is equal to t of 6 minus 1 plus t of 6 minus 2. So to find the sixth term, I need to add the fifth term and the fourth term. Okay, so that does indeed work. Let's go ahead and look at this one here. So this is just about kind of notation in terms of what it means. So here we're saying if n equals 3, then find n minus 1. So in other words, that's t of 3 minus 1 is 2. Another way of saying it is if I'm talking about the third term, this is talking about the one before it. So going backwards 1. Well, t of 2 is 1, 2, 3, 4, 5, 6, 7 are the terms. So t of 2 is negative 4. Here, this is saying if a term that we're talking about is equal to 2, so we're talking about this one here. This one here is n plus 1. So in other words, this must have been n, and then the one before n is right here. So let's look at that again. So t of 2 is right here. So 1, 2, 3, 4, 5. So t of 5 is equal to 2. Another way of looking at that is saying that means that this must have been t of 4 plus 1. And this one must have been t of 4 minus 1. Well, 4 minus 1 is 3. 1, 2, 3. This is our third term, which is what, negative 2. So let's look at this again. This one here is saying n, if I want to know the one after n, it's 2. So this must have been the one that I was referring to. And this is the one saying the one before n is negative 2. So though you can absolutely use plugging in numbers, which is sometimes really helpful, sometimes it's helpful talking about things that are coming before or after as well. So here we're talking about the fifth term, and this one here is I want the one that's 2 after the fifth term. So the fifth term is 1, 2, 3, 4, 5. And the 2 after the fifth term is this one. Wait, did I get that right? 1, 2, 3, 4, 5, yeah. And the 1, 2 after that would be 6. Here, we're saying t of n plus 1 is 2. So we're back to this one again here. And remember, that really means t of 5 is equal to 2. So if I want to figure out what 6 is, there's a couple different ways of looking at it. I can say 6 is t of 7, because 2 more. Or I can say 2 more than what we have here. I can say n plus 3 is equal to 6. So if I'm talking about this one versus this one, if this is plus 1, this is plus 2 and plus 3. So there's kind of two different ways that we can look at writing that solution.